Okay, so in 13.1, there are two main things. And the first thing is learning these, which are three new trig functions. We know that when you have a right triangle, straight across from the angle in question is the opposite, the one next door is the adjacent, and over here is the hypotenuse. But when you're missing a third side, you want to keep in mind a squared plus b squared equals c squared. That can be really easy or really tricky depending on the values that you get. And the reason I picked this example is if I do 4 squared, I end up with 20 as my c squared. So I get root 20. If I put that or any form of that into IXL, it's going to mark it wrong. And so what we want to do is we have to think back to when we did radicals and remember that 4 is a perfect square that fits into 20. And so 2 root 5 is actually how I would have to write or think about this third side. So that's not new, but that's what's going to make the new lesson kind of tricky. We know that sine compares opposite to hypotenuse. If you flip that over and do its reciprocal, you get its reciprocal partner, which is secant. So you're responsible from now on for knowing cosecant, which is abbreviated CSC. And what that's asking for is the relationship of the hypotenuse over the opposite. So they are flip-flop versions of each other. And that's what we want to know moving forward. That's the new thing. Cosecant, which is adjacent over hypotenuse, also has a reciprocal pal, and it's called the secant, abbreviated SEC. And so instead of adjacent over hypotenuse, it's the hypotenuse over the adjacent. Last one is the tangent, and it has a partner called the cotangent. And the cotangent is going to be, instead of opposite over adjacent, adjacent over opposite. So I'm just going to mute everybody because there's some background noise. Okay, so this can be really easy. Like if I had a triangle like this, where I had 3, 4, and 5, which is nice, easy numbers, then my sine of theta would be opposite over hypotenuse, and my cosecant would just be 5 over 3. I just flip them. If I had a cosine then of adjacent over hypotenuse, my secant would be hypotenuse over adjacent. Nice and easy. Those are my answers. Type them into IXL. I'm good to go. Tan theta would be opposite over adjacent, and my cotangent of theta would be adjacent over opposite. So when you start doing IXL, that's what it's going to be asking you for, and it'll seem pretty easy. You just have to remember to use Pythagorean theorem to find a third side if it's not there, and then you can just kind of take your time and say, okay, they're asking for the cosecant. That ties back to the sine. So instead of opposite over hypotenuse, I'll flip that and write my answer. But last thing, then I'll let you go. What if I had this problem that I started with? And in this problem, I'm supposed to type my answers in as radicals, simplified radicals. Hopefully you can see this. So the sine of this would be opposite over hypotenuse, but there's two things wrong with that. The 2's cancel, so now I have 1 over root 5. Well, if I was asked for the cosecant, then my answer would be root 5 over 1, which is just root 5, because those two are flipped versions of each other. This, if I try to type it into IXL, it's going to mark it wrong and take me back a step. Because remember back to the math we've done in the past, you can't have a radical on the bottom. So you rationalize, you'd end up with a regular 5 on the bottom and a 1 root 5, which would just be root 5 on the top. So those are going to be the things that make the IXL tricky, which is why I recommend taking your time as you go through it, so you don't kind of know what you're doing, but you type something into it incorrectly, and as a result, you go backwards in your SMART score. So what if I was asked for the secant? Well, I'd be thinking, okay, that's related to the cosine. So instead of adjacent over hypotenuse, I'll need hypotenuse over adjacent. So that's going to be 2 root 5 over 4. I don't have an issue with the radical since it's not in the bottom, but these reduce. So on my IXL, I would enter my answer like that. And on IXL, you're going to see down below this little fraction option and a root option. So to type that in, you'd pick this, and then it'll set up your answer space as a fraction. Then here you'd pick the root, type in your 5, and then go to the bottom box and type in your 2. So just be careful about how you're answering. If they wanted the cosine, I'd end up with my adjacent over my hypotenuse. This reduces, so now I have 2 over root 5, but with 2 over root 5, I need to use rationalizing. So the answer I would have to type in to my IXL would be 2 root 5 over 5. And last, for this one, the tangent would be the opposite over hypotenuse. So I would, opposite over adjacent. So I'd reduce that down. And then my cotangent, which flips that over, would be 4 over 2. And so I would type in a 2 as my final solution. So, I'm trying to get you all unmuted here. So at this point, the problems all stem back to the same thing, which is remembering which one's part of which, but your job gets harder as you have radicals involved.